Okay, let's continue our notes. So here we have the same reaction, potassium phosphate with silver nitrate to produce the silver phosphate and the potassium nitrate. This is already in your notes. Again, we already know the amount that we have for each one, and each one is 2.50 times 10 to the negative 3 moles. Now, these notes are going to tell us what happens after we know which one is the limiting reactant. So the limiting reactant, remember, is the one that's going to run out first, and it's going to dictate how much product forms. So in our previous notes, we figured out that the limiting reactant was going to be the silver nitrate, right? So we said that this guy was going to be the limiting reactant, and this guy was going to be the excess reactant. So the one that's going to dictate how much product is formed is going to be the silver nitrate. Now what we have to do is we have to take that limiting reactant, okay, and then create a mole ratio to whichever product we want to determine. In this case, I want to figure out how much silver phosphate is formed, right, which is this guy right here. So what we're going to do then is I'm going to create a mole ratio. Let me get my highlighter real quick. Okay, I'm going to create a mole ratio from my silver nitrate. Probably should have used a different color. Okay, to my silver phosphate. That's going to be my mole ratio. So let's go ahead and set that up. The mole ratio is going to have a very simple model. You're going to have, you're going to have the desired product, okay, over the limiting reactant. So your mole ratio is going to be the desired product over the limiting reactant, right? That's going to be how we write the mole ratio. Now, what I'm going to do here is I'm going to change the color, and we're going to say, let's write the mole ratio. Okay, because we have our model now. So our mole ratio then is going to be 1 mole of silver phosphate is produced for every 3 moles of silver nitrate that reacts. Okay, whoop, I wrote that wrong. There we go. All right. So this is our mole ratio. Now that we have our mole ratio, then we need to determine then how to calculate the amount of product. So whenever you're going to calculate product, okay, you're always going to start with the amount of the limiting reactant. In this case, that's this amount right here. It's 2.50 times 10 to the negative 3. It's easy in this case because both of these have the same value, right? But in a situation where those values would be different, you would always start with the value of the limiting reactant, which is this guy right here. Okay, so we're going to set this up. That's going to be our starting value. So I'm going to put that in blue to show that that's our limiting reactant. So 2.50 times 10 to the negative 3 moles of silver nitrate. Now, I'm going to multiply that by the mole ratio. Now, if you set it up in this model, right, where you have this model here, where you have desired product over limiting reactant, then you shouldn't have to worry about flipping the mole ratio because it should already be set up. So if I multiply it by the mole ratio, then I'm going to have 3 moles of silver nitrate. And then in this case, the desired product is going to be 1 mole of silver phosphate. Okay, so you see how we're setting this up? All right. Now, if I look at this, right, I'm going to put this over 1 to make sure that it's a fraction. All right. Look what happens to your moles of silver nitrate. Those are going to cancel. Now, if those cancel, then whatever answer I get is then going to be in moles of silver phosphate. So the mole ratio allows you to convert from moles of one substance to moles of another. That's how we're able to calculate unknown quantities and using a balanced chemical equation because we're able to do the stoichiometry and figure that out, right? The stoichiometry is just basically using the mole ratio. All right, so if we multiply everything straight across, right, then we're going to end up, I want to start down here, okay, with 2.50 times 10 to the negative 3 moles of silver phosphate, because remember it's just times 1. Okay, and then I'm going to put that over just 3. Remember, it's just 3 now because the units got canceled. So if I divide this out, I should end up with 8.33 times 10 to the negative 4 moles of silver phosphate, right? So by doing the stoichiometry here, you can see that I end up with moles of silver phosphate as my answer. So that's what the mole ratio allows you to do, right? It allows you to convert from units of one to units of another, all right? Now, if I wanted to figure out from here, right, how many grams that is, well, then all I have to do is take this amount, right? Because now I'm in moles, right? So 8.33 times 10 to the negative 4 moles of silver phosphate, right? Basically setting up a new conversion here. Okay. Then I'm going to multiply by the molar mass, right? The molar mass in this case is 1 mole of silver phosphate, all right, is equal to 418. Whoops. There we go. 418.574 grams of silver phosphate. If you don't remember how to calculate molar mass, let me know and I'll upload a video, but it should be pretty straightforward. Okay, so here is my conversion factor. Again, this is the molar mass, right? I'm going to abbreviate as MM. The molar mass allows me to convert from moles of one substance to the grams of that substance using the molar mass, because the molar mass is the mass of that substance, or 1 mole of that substance, right? So all I got to do then is figure out which one I'm going to put on top, which one I'm going to put on bottom. Okay, so in this case, 1 mole, I'm going to keep it the same color, of silver phosphate has a mass of 418.574 grams of silver phosphate. Now, don't try to remember, oh, do I multiply? Do I divide when I'm going from grams to moles or moles to grams? Don't try to remember that. Always set up the conversion, and the conversion will tell you exactly how you need to do it. In this case, because I have it set up in this way where the moles cancel, I'm going to multiply straight across. So to get this answer, I'm going to take 8.33 times 10 to the negative 4, and I'm going to multiply it by 418, and that should give me my answer, which is 0.3488 grams of silver phosphate. Okay, and there it is. So in this reaction, with the amount of reactants that we had, right, then we should produce 0.3488 grams of silver phosphate. This is how much should form in this reaction. Okay? Okay, guys, that's it for this video. I wanted to make sure it's nice and short. Remember that the stoichiometry has to do with the mole ratios. You have to learn how to use these mole ratios, because the mole ratios are what's going to allow you to figure out all the unknown quantities in any given balanced equation. All right?